Today we'll talk about piecewise functions and look at a couple examples. Here's an example of a piecewise function. A piecewise function is a function that's defined in two or more parts or pieces. This first part of the function only works when the input or the domain would be x less than 0. So that would be values like -1/2, -1, -2, -3, -4, etc., including decimals, fractions, and integers. The second piece or the second part of this function is defined when the input is greater than or equal to 0. So that would mean if you had 0, +1/2, +1, +2, +3, etc., again including all fractions and decimals as well. So you have to decide what your input value is and which piece of the function it should be substituted into. Notice on part A, I have a negative value for my input. Negative values go with this first part or this first piece of the function. So I must substitute that in to the top of that function only. I will not get the correct answer if I substitute it into the bottom or the second part. So let's go ahead and substitute it in. 4x plus 5 is 4 times -2, which gives me -8 plus 5, and that's equal to -3. So we would say f of -2 equals -3. That's my first answer. Now notice the second input for part B problem that I have is 0. There is only one piece of this function that's defined for x being 0, and that's the second part, as you notice here. So I must substitute my 0 into that second piece of the function. I would say f of 0 equals 0 plus 6, because that's substituting it into the x plus 6. When I work that out, I just get 6. So f of 0 is equal to 6. Last but not least, I have an input of 3, and it's a positive value. If you notice, the positive values also use the second piece of this function. So I have to substitute f of 3 into 3 plus 6, because that is the x plus 6 part. 3 plus 6 equals 9, and f of 3 is equal to 9. Here's another example. Notice the domain input values have changed a bit. On the first piece of this function, I would use it anytime x is not equal to 2. That means x can be any number except 2. It can be positive, negative, it can be a decimal, a fraction. Just remember, when the input is any number except 2, we use the first piece of this function. That's the top part. However, if you do have x equals 2, then your answer is automatically 7. So if x is the value 2 in the input, remember x is domain or input, then the answer here is automatically 7, because 7 is written out to the side. Now, working part A, my input is 3, so I would have to use the first part of my function. I would substitute in 3 squared minus 4 over 3 minus 2. That's going to be my h of 3. I have to work it out because it's not a 2 as my input. Well, that will give me 9 minus 4 and 3 minus 2, which will give me 5 over 1, which is just 5. That is my answer for part A. Part B has an input that is not 2. So I would again use the first piece of this function to work it out. h of 0 equals 0 squared minus 4 and 0 minus 2. When I work that out, I get negative 4 over negative 2, which will reduce to be the number 2. The answer for part B then is 2. Last but not least, I have an input that is a 2. Now remember, this was a little strange, but when the input or the x is 2, the answer is supposed to be 7. That's just how this problem defines it. So I would say that h of 2 is equal to 7, and there's nothing to work out because only 7 was given out beside that parameter.